Welcome to this explainer. Look, if you've ever stared at a blank document titled Lab Report and felt a sudden wave of sheer panic, you are absolutely not alone. Today, we're going to completely demystify the strict, almost mathematical structure of a university science lab report. The goal here? To make sure you never lose easy marks on perfectly good science. We're going to break down exactly what your professors are looking for step by step.
So, here's our roadmap for today. We'll start with the golden rule, move to the top of the hourglass, dig into the materials and methods recipe, tackle handling your lab data, explain what widening the hourglass means, and then wrap the whole thing up with citations and a final checklist.
All right, let's jump right into section 1, the golden rule.
Before you even type a single word, there is one step that's honestly more important than the experiment itself. You've got to read your professor's instructions. You see, in university, there is no universal template. Every single professor uses a completely different style guide. Some of them might want a highly formal 5-page paper, while others might just want a quick results and discussion summary. So whatever you do, do not assume the format you used in high school or even in a different class last semester is going to work here.
For example, your professor might ask for some very specific things. They might say, use exactly APA 7th edition for all citations, or strictly avoid personal pronouns like I or we. Maybe they want all raw data in an appendix, or they limit your abstract to exactly 200 words. If you ignore these specific prompts for formatting, citations, or word counts, you can literally lose major marks, even if your actual science was absolutely flawless. The science alone just isn't enough. You really have to play by their specific rules.
Moving right along to section 2, top of the hourglass.
Let's start building this document from the top down. First up, your title. It needs to be highly descriptive. Fight the temptation to be purely creative here. A title like The Bouncing Ball might sound catchy, sure, but the effect of gravity on the rebound height of a 50-gram rubber sphere? That tells the reader exactly what variables are at play. Save the mystery for fiction, right? And science, we want a spoiler right there in the title.
Next is your abstract. This is just a one-paragraph summary of your entire paper. And here is a huge pro tip for you. Write this last. I mean, you can't really summarize an experiment you haven't fully written up yet, right? When you do write it, make sure it cleanly hits 4 specific requirements. State why you did the study, what you did, what the main result was, and finally, your overall conclusion. It's basically the elevator pitch for all your hard work.
Now, think of your introduction as an hourglass. You start super wide, introducing a broad scientific concept, like, say, photosynthesis. Then, you funnel the reader down to your specific problem. Finally, at the very narrowest point, the neck of the hourglass, you drop your hook. And that is your hypothesis. This is a clear, definitive statement declaring exactly what you predict will happen and why.
Okay, section 3, materials and methods recipe. So as we hit the narrowest part of that hourglass, strict procedural detail becomes absolutely everything. This section is quite literally a recipe. It has to be written so clearly that another student could pick up your report, walk straight into the lab, and repeat your experiment perfectly. That means ditching vague terms. Instead of saying you used a beaker, specify that you used a 100 ml graduated cylinder. Instead of acid, note that it was 0.1 m hydrochloric acid. Precision is the absolute backbone of reproducible science.
Now, the crucial point here is how you phrase this recipe. You must strictly use the past tense to describe what was already done, rather than writing it as a present tense command. Remember, you aren't writing an instruction manual telling someone else to heat the solution. You're reporting on history. The solution was heated. Using this objective, passive voice is a major hallmark of scientific writing.
Let's dive into section 4, handling your lab data. Moving out of the methods, this is where students often get a bit tripped up. The most important thing to remember is that your results section is strictly for reporting facts. There is absolutely no room here for opinions, interpretations, or explanations of why something happened. Not yet, anyway. You are simply presenting the evidence, relying on tables for your exact numbers and graphs to visually display the trends.
It's also super vital to understand the difference between raw data and process data. Please do not dump your messy, raw lab notes right into the middle of your report. Those raw numbers usually belong tucked away at the very end in an appendix. Your main results section should only feature your process data, the clean averages and final calculations you made from those raw numbers. You want to keep the main body of your report sleek and highly readable.
And when you're formatting this processed data, you must never leave a number hanging out there naked.
In science, a number without a unit is completely meaningless. Is 5.2 the mass in pounds, kilograms, ounces? Always, always include the proper units of measurement, like grams or milliliters, right next to your values.
While we're on the subject of visuals, you have to remember to caption absolutely everything. And there's a very specific rule for this in the science world. Carefully place your titles above your tables and put your explanatory captions below your figures and graphs. This ensures the reader knows exactly what they're looking at without having to hunt through paragraphs of text for context.
All right, section 5, widening the hourglass.
Now, as the hourglass widens again for the discussion section, the very first thing you need to do is directly and honestly answer this question. Did your factual data actually back up your initial prediction? Look back at that hypothesis you made in the introduction. Look at your process data and clearly state whether they align. And hey, it's perfectly okay if they don't. Science is about finding the truth, not just about being right.
In fact, if your data looks completely wrong, don't panic. This is actually where the magic happens. Discuss your sources of error. Was the equipment old? Was there an unexpected change in room temperature? Here is a massive secret for you. Professors actually value your ability to critically analyze sources of error way more than they value perfect data. A thoughtful explanation of why an experiment failed shows far more scientific maturity than a perfectly fudged dataset ever could.
You'll wrap up this discussion section by looking at the true big picture. This is the widest part at the very bottom of our hourglass model. You've got to connect the findings of your specific, narrow experiment back to the broader scientific concepts you've been learning about in lectures. How does your bouncing rubber sphere teach us something fundamental about the laws of physics? This is where you tie it all together.
Finally, section 6, citations and final checklist.
In science, you stand on the shoulders of giants. That means you have to give credit to the ideas of others. Use the exact citation style your professor requested, which, again, is very often APA format. And don't forget this one, this often includes citing your own lab manual. If you didn't invent the protocol from scratch, you need to cite exactly where you found it.
So right before you submit that document, run through this simple mental checklist. Did I follow the professor-specific formatting from the golden rule? Are all my tables and figures properly labeled? Did I consistently use the past tense in my methods? Did I include all my references? Taking just 2 minutes to double-check these simple formatting rules will absolutely secure easy marks that other students just throw away.
Writing these science reports is a distinct skill, and like any skill, it just takes practice. But if you honor that hourglass structure, stay organized with your data, and respect the golden rule, you're going to easily find your rhythm. You now have the exact blueprint to turn messy lab data into a perfect grade. So, with this toolkit in hand, what complex scientific mystery are you going to confidently decode next? Happy writing!